So my next topic that I would like to talk to you about today is deploying and provisioning an enclave technology, or T, in a data center environment. So before I begin, mandatory disclaimer, this talk is not intended to represent any current or future GCP products or deployments. Any information disclosed in this talk is subject to change without notice and might never materialize into anything. So with that aside, in this talk, I want to focus on the following questions. So first, how do we deploy a T, trusted execution environment, at scale in a data center? How do we provision hardware identity across a very large fleet of machines? And what kinds of challenges arise in the process of doing these things? So I will be speaking from my experiences working on deployments of Titan, which is Google's own hardware root of trust, as well as SGX. So we are still designing our data center infrastructure to support SGX, but our overall deployment strategy draws heavily from our experiences with Titan. And I do think that deployments of other hardware Ts will likely face many of the same and similar design considerations and challenges that we have had with Titan. So let's start with the first question here. How do we deploy a T at scale? So clearly it is not as straightforward as just deploying the hardware. So when introducing a new T to the data center, our first step is to enlighten our machine installation flow about the software and configuration that is required to both enable and support Enclave capability on that platform. So this involves managing the various software layers on the machine. Firmware packages, BIOS, kernel modules, system daemons, and any other software packages that are necessary. So before we can actually run any Enclave workloads in our data center, we need to fulfill a second requirement, which is to provision hardware identity across our fleet. And this is so that a job running on a machine can make use of that machine's hardware identity for attestation. So there are several different provisioning scenarios that we need to handle in our data center. So initial provisioning is what happens when a machine first arrives in our data center and its hardware identity is installed for the first time. So in the case of Titan, what this looks like is during manufacturing, we harvest certification requests from each device. These payloads are shipped to Google, and we then process them with the offline Titan CA, the root of trust for the Titan identity system. Once a part arrives in our data center, we can provision that device with its certificate. So in the case of SGX machines arrive with unique hardware keys and fuse, and that seeds the SGX key hierarchy on that machine. So we use that hardware identity to certify an attestation key that is wielded by the quoting enclave that runs on that machine. Since Intel is the root of trust for SGX identity, our provisioning infrastructure must contact Intel services to obtain certificates for our machines. So another type of identity provisioning event is a rotation of an attestation key. So the idea here is that we would regularly rotate the attestation key on our machines just to maintain good key hygiene throughout our fleet. So for SGX, what this looks like is we would generate and certify a brand new attestation key in our quoting enclave using the same underlying hardware identity. So perhaps the most interesting provisioning event, as well as the most complex, is provisioning after a recovery of our trusted computing base, or TCB. So after a TCB recovery, a machine needs to be provisioned with an identity that is only accessible to the higher TCB. And we would, of course, create and certify a new attestation key after that. So this flow is very similar to initial provisioning, except that the machine already has a previously installed hardware identity. So to support identity provisioning across our fleet and our data center, we must build out several core infrastructure services. So one of these services is a certificate store that caches certificates issued by a CA, like our Titan CA or Intel's SGX CA. We also have a core service that is responsible for coordinating provisioning flows across our fleet. So this coordinator service may contact internal or external services in the process of provisioning a machine. So the last requirement I want to discuss is making our job scheduling infrastructure T-aware. So at Google, as you might know, the infrastructure responsible for scheduling and deploying jobs is called Borg. So Borg understands the resource requirements of jobs and schedules them to machines that meet their requirements. So we must enlighten this system about what kinds of Ts are available in our data center, as well as what security properties they have, which machines have enclave capability, as well as how to allocate certain resources related to enclaves, like, for example, SGX EPC. So here's a quick glimpse of what our identity provisioning infrastructure might look like. So we have a provisioning coordinator service that walks through our fleet and reaches out to machines to get them provisioned with their hardware identities. So this service would contact the certificate store or any other service necessary to obtain a machine's certificate. So we've talked a bit about the requirements for deploying a T in a data center, as well as how we design the identity provisioning infrastructure for our data center. So what we've learned from our experiences with Titan is that there are many unique challenges that arise when we attempt these kinds of deployments at scale. So one of the most fundamental requirements for a T deployment is that machines must be provisioned with their hardware identity before running enclave workloads. So when we're working with data center scale deployments, getting 100% of machines provisioned is actually quite hard. So there are instances where we cannot provision a machine due to any number of reasons, ranging from hardware failures to outdated software on that machine to even downtime of services that are in the provisioning path. So if the failure to provision occurs during TCP recovery, we always have the option to fall back to older credentials, older identity on that machine. If the failure is at initial provisioning time, there's unfortunately not a lot we can do to enable attestation on that machine at that time. So one thing we can do to avoid wasting machine capacity that could be used for running other types of workloads is to deploy the machine anyway, since there are still opportunities to provision that machine for enclave workloads later on. So this is one strategy that we've actually used in our Titan deployments. So another big challenge is scaling our infrastructure. So hardware identity provisioning for a large fleet is an ongoing process. We can expect that at any given time, there are new machines arriving in the data center and getting their hardware identity provisioned for the first time, as well as many machines having their attestation keys rotated. When a TCP recovery occurs, we can expect that our provisioning infrastructure will handle many provisioning events within a short time frame. So it is necessary to design the identity provisioning infrastructure so that each component is able to handle the maximum QPS expectations, which we would typically calculate based on a TCP recovery event. So TCP recovery itself is a particularly tricky problem. So we want to update our fleet to the newest TCP as fast as possible. We also want our attestation verifiers to stop trusting attestations originating from machines that are running an out-of-date TCP. So we have learned from Titan that it actually takes quite a while to update TCP across a large fleet of machines. So there's always a long tail involved in the update process. So for some window of time, we actually have to allow for multiple TCPs to be trusted. So Ts like Titan and SGX provide a strong binding between identity and hardware. And this is a powerful property that allows us to make statements about how and where workloads are running. So we need the ability to correlate this with our machine inventory so that we can detect and fix misconfigured machines. So for example, we want the ability to identify machines that are producing unverifiable attestations. We also want to detect machines that have failed provisioning and are completely missing a hardware identity. So with sufficient metrics and monitoring systems in place, we can identify, debug, and remedy these types of issues as they come up. So I can only begin to scratch the surface of these topics in a very short talk, but I hope that what I've shared today can lend some insight into industry deployments of Ts and the kinds of considerations that we have when deploying them at scale. Thank you. Okay, yes.
Sounds like to do this at scale, there's a number of things with the trust model that get kind of complicated. Sorry, I'll say it again. So when you're looking at the TCB, is there a good set of rules of thumb that you use for looking at the trust boundary and trust guidelines? The reason I'm asking this is when you have a partial TCB recovery, it sounds like there's ways you can make it faster if you knew exactly what was wrong, versus just installing everything from zero. And I was wondering how you looked at that.
Right, so there are different components of our TCB that might be upgraded. It could be something just like a bug in one of Intel's enclaves or our quoting enclave, or it could be something that has to be remedied by microcode patch or something. So we have different, I guess, delivery models for how to provide those updates in our fleet. They can be more or less disruptive based on which component it is. So we do take that into consideration so we don't just completely reinstall everything on the machine. Yeah.
Thank you.
Yes.
Hi. From the structure of the machine provision, looks like there is a centralized point. Yeah, this one.
Yeah.
So you do have a centralized provision center.
So you can imagine that this provisioning coordinator is under the direction of maybe even another system that is more aware of which machines require updates, when was the last time they went through key rotation, that kind of thing. So there does need to be some central entity that keeps track of these things so that we can trigger provisioning flows on machines when they require it.
Okay. And the other is sounds like this ID is machine-based, and although you have a rotation of the key, so sounds like the machine credential is per machine. So in case a attacker, for example, I would run some malware and rotate and randomly flashing between machines, could confuse your central provision because it looks like everybody were naughty at a certain time, then you shift the bad behavior to another machine.
Can you clarify exactly what the question?
Yeah, we can talk.
Okay, sure.
If you
Yeah.